there is again the materials which are used for bearings and their properties. Now, application of bearing materials of plain bearings. So this I have covered. Now, zinc you can see used during operation of steel. Some problem. Okay. So this is then zinc here and porous metals. Porous metals, such bearings are particularly good for slow speed, reciprocating or oscillating motion. Graphite is a typical type of material. It's a graphite over metal alloy. Is formed from molten metal, graphite and carbon. It's a uniform solid self-lubricating bushing and bearing material. From this material, we manufacture a unique self-lubricating bearing solution offering superior performance in hundreds of applications. So graphite material is suited for submerged or high temperature bearings or bushing applications where oil, grease and plastics fail. So this is a special type of bearing material. Then features or benefits of graphite. So it is self-lubricating. It can operate in hot temperature, cold temperature, and dry and wet conditions, dimensional stability, chemically resistance, low coefficient of friction, linear motion, current conductivity, eliminates sparks and static, conducts well, acceptable for it is acceptable as per the FDA accepted for poor services, no lubrication, to drip or clean up easily, steam clean. Graphite for high temperature bearings. Now you can see the applications here. I don't want to show all these. In the bakery, and this is also in the case of pulp and paper industry, you can see all these applications. For food industry, now after seeing these applications, we will just have some parameters for bearing design. So design of boundary lubrication bearings. So how do we design the boundary lubricated bearings? The factors to be considered when selecting materials for bearings and specify the design details include the following. Coefficient of friction, both static and dynamic conditions should be considered. Load capacity, P is the radial load divided by the project area of the bearing. So small p is the radial load divided by projected area, that is Newton, it is in pascals, Newton per meter square. Speed of operation V, which is in meter per second. Temperature at operating conditions, wear limitations, producibility, machining, molding, fastening, assembly and services. So these are the factors which you have to consider when you design a plain bearings or boundary lubrication applications. So especially PV factor, you can see PV factor is the very important case of plain surface bearing design. Please remember this. So this is PV factor. The product PV is the product of load divided by projected area multiplied by the velocity of the shaft. So therefore PV can be thought of as the rate of energy input to the bearing per unit of projected area of the bearing if the coefficient of friction is 1.0 in SA. In SI units, PV is equal to kilo megapascals. So we always represent it by kilo pascals meter per second. So units of this are pascals meter per second. So we represent PV factor by kilopascals meter per second. It is actually the energy unit. because if you divide force divided projectile area multiplied by velocity, it should come equal to this. Now you can see here, always you have a chart. Whenever you go through some book of bearing design, you will always see their PV factor. So PV factor is here. It is the ratio of P versus velocity. So you have to make trade-offs. If the P is high, then how much velocity you will select for the material. So if the P is high, you have to use low velocity. If P is low, then the velocity you can choose higher. So this is typical PV curves for thermoplastic, PTFE plus fillers, porous bronze plus PTFE plus lead, PTFE plus glass V plus thermoset, reinforced thermoset plus molybdenum disulfide, thermoset carbon graphite PTFE. And you can see here, this is the typical material curve here. This one. P is maximum here, V is maximum here. So it's a typical material. You can see the graph of this material. So rest is here for the other materials which I have shown on the left side, and these are the curves of P and V. So P is meganewtons per meter square and V is velocity. So PV chart for the bearing. Very important to see the P. You can select the bearing from this point. If you know the PV value, you can directly select the bearing. So there is no need, then you can directly use this chart and you can know which type of material used for particular bearing application. Operating temperature, most plastics are limited to approximately 200 degrees Fahrenheit, 93 degrees centigrade. However, PTFE can operate up to 500 degrees, that is 260 degrees Celsius. Babbitt is limited to 150, while tin, bronze, and aluminum can operate up to 260. A major advantage of carbon graphite bearing is their ability to operate 400 degrees Celsius. Please remember, this is operating capability of various materials used for plain bearings, and you can have carbon graphite has the highest capacity to operate up to 400 degrees Celsius. Remember this. Whenever you will get some P value and the temperature is high, you can use carbon graphite. But the graph alloy bearings are typical bearings. They are not commonly available. So wear factor. You have to know two things very essential for the design of bearings. That means two material properties must be known to you. What are those two material properties you must know? One is the PV factor and coefficient of friction with it. That the second is wear factor. Because if you know coefficient of friction, you can know how much the bearing will generate the PV. It will depend upon the coefficient of friction. If coefficient of friction is low, the PV capability of the bearing material will be higher. If the coefficient of friction is high, then PV capability of the bearing will be low. So wear will depend upon its wear capability. So we are using the wear factor to measure the wear of the material of the plain bearings. So wear is measured as a volumetric loss of material as a function of time, the load and the velocity effect wear. Thus K is defined as K is equal to W divided by FVT, where W is wear volume. You can represent it by WV also, and you can simply represent it by W. That depends upon you what type of designation you will give to wear volume. And you can represent it by V also, V small w. F is applied load, V is linear velocity, T is time. Note that the K factor and the above equation may not be used to predict the actual wear in the application. The K factor only allows the comparison of relative wear among the alternative materials. Because wear can change at operating stage, so you cannot exactly get the value of the machine life of this plain bearing life based on this, because at the operational stage, some conditions may change and the wear capability of that bearing material will reduce drastically, or it may have higher values also if the conditions are favorable for the wear. Now, what is the design procedure for the plain bearing? First of all, you must know, you must understand that if I have a bearing here like this, you can see plain bearing like this. So this is the bearing. If I cut half of this, then this will be the length and the diameter of the bearing. So it is shape is always, whenever you have to calculate the, you can see here. So whenever you have to calculate the projected area is different from the section, the other area of this bearing. So projected area will actually determine the area of the bearing. So if I open it, the projected area will be D multiplied by L. So if I open this bearing, projected area will be D, this will be the projected area of the bearing. Okay. So projected area is always diameter multiplied by length. So whenever you have to design a bearing, you will be given radial load, you will be given the speed, and nominal or minimum shaft diameter will be given to you. That for that application, you have to design a bearing. Now, after you get this radial load and speed of the rotation and minimum nominal diameter of the shaft, your objective of design process should be to specify the nominal diameter length of the bearing and a material that will have safe value of PV. Now, as I told you, PV has very important factor, plays an important role for the life of the bearing vis-a-vis with the wear. So you have to select the diameter and length of the bearing, and then on that basis you will find the value of PV and you will see which material will be able to give that PV factor. Because the PV factor for particular material is given. If your bearing material is able to give you that much PV factor, then you can use that material for design of plain surface bearing. Now the first setup is, in the design, is specify a trial diameter. Now how we will specify the trial diameter? When the nominal diameter of the journal is given, you can select your trial diameter little bit higher than that, considering some clearance, isn't it? So if your shaft diameter is say 60 centimeters, 60 mm, you can select the 65 mm as the diameter of the bearing. So once you specify the trial diameter, then you have to find the value of length of the bearing. Obviously, because you have to find the projected area. Now, for that purpose, you have a relationship, empirical relationship, that L by D varies from 0.0 ratio of L by D, as you see here. L by D is here. Now, ratio of L by D is varies from 0.5 to 2. So you can select, depending upon the space available, L by D equal to 1, L by D equal to 0.5, L by D equal to 1.5, it depends upon you. So generally, for oil impregnated bearings or porous bearings, we select L by D equal to 1. For carbon graphite bearings, we select L by D equal to 1.5. Because I told you carbon graphite bearings have higher capability of temperature. So as you increase the L by D ratio, that means length and will increase also, and diameter, as diameter for its diameter, then the bearing will generate higher temperature and should be able to withstand higher temperature. That is why for carbon graphite bearings, L by D ratio is taken higher, that is 1.5. Please remember this. And this will be able to only when the bearing has higher capability of temperature. Then you have to compute L on the basis of this. After finding the L, what you will find? Compute the bearing pressure. How you will find the bearing pressure? P is equal to F L by D, because radial load will be given to you. L you have found here. D is also given. So you can find the value of P. After finding the P, you can find the value of speed of the bearing on the basis of this D pi dn divided by this. Isn't it? Once diameter is given, speed of the journal is given, you can find easily the velocity of the bearing. So that is pi dn divided by 60 meter per second. Then you can compute PV value. That means pascals meter per second. So you know the P, you know the V, you can find PV. This PV you have to multiply by 2y, because to obtain the design value of PV, as in the case of belts and in the case of chains, we find the rated power or design power. Here we are finding the design value of PV, on the basis of which we design the bearing, and it is not equal to PV, but it is equal to twice PV to take into consideration the operational factors. So if your PV is 1, you have to find the value of the bearing material, which gives you equal to 2, or it is 10, then it should be able to, the bearing material should be able to give you the value of 20 pascals meter per second. Then after finding this twice PV value, you can select from the table or from the chart which I have shown you just now, which type of bearing will be able to, which type of bearing material will be used for this. Now before I give some numerical, but I will also mention here that another factor which is very important is that to find the life of the bearing. Once you design the bearing, you have to find life of the bearing. So it is very important. So for the finding the life of the bearing, you have to use wear factor, and that I will discuss with you when we study some numerical. How do we find the life of the bearing? Because once the bearing wear takes place and if the clearance increases beyond the specified clearance, it will start creating noise, and the function of the bearing will not, performance of the bearing will get deteriorated. So you have to be another factor which you have to see, that what is the life of the bearing when it crosses the clearance which you have for which you have designed. So here you can take any example and you can use it for designing the plane surface bearing. So for example, complete the design of the bearing system considering diameter clearance, lubricant selection, lubricant supply, surface finish specification, thermal control, and mounting consideration. So these are the things which you have to mention: diameter clearance, lubricant selection, lubrication supply, surface finish, thermal control, and mounting consideration. I will also here mention that there are various types of expansions taking place in the bearing. You have to consider clearance. When you give the clearance, you have to consider those things. For example, the thermal expansion will be there. Lubricant, whatever is the space to be left for lubricant, that you have to consider. Thermal expansion of the bearing which takes place. So these things are to be considered, and also for maintenance, clearance is to be considered. So you have your clearance is based on 2 or 3 factors. That much clearance you should provide always in the bearing. Otherwise, bearing will fail. So that's another consideration in the design. So one is, I must summarize now. One is PV factor. The other is operating temperature. The wear factor. diameter clearance, lubricant selection. How do you supply the lubricant? Surface finish of the surfaces, thermal control, and mounting considerations. All these things are design decisions, and designer has to design bearings on these bases. Just by the numerical, by finding the values of PV and wear, you cannot escape from the design of the bearing completely. So I am here giving small example first of all, which is a bearing is to be designed to carry a radial load of 667 Newton from a shaft having a minimum acceptable diameter 38 mm and rotating at 500 RPM. Design the bearing to operate under boundary lubrication conditions. As I told you in the beginning also, you have to design the bearing for fluid surface bearing under boundary lubricating conditions. And as I told you, you will be given some nominal diameter of the shaft. You will be also given the radial load. You will be also given the speed of the journey. So if you see, you can find out the given parameters is radial load 667 Newton, then speed is 500 RPM, journal diameter is 38. Now you can take trial diameter D is equal to D minimum 38. That's I have taken the same as, but you can take 39 also, 40 also. Then L by D I have taken 1 and L is equal to D is equal to same. Bearing pressure I have calculated here easily. Newtons per meter. You can pay. So this will become megapascals. And then since you know D, you can find the value of velocity. After you finding the value of velocity, you can find the value of PV factor. So PV is coming here equal to 459.1395 megapascals. So once you find this, you will multiply it by 2 and you will get the design value of the PV for which you had. Then from this graph, here you can see in the step 9, from the table below, we could use a bearing made from high tin Babbitt having a rated value of PV is equal to 1050 kilopascals. So you see from this, this table, there is PV value given and there is material given. So you will find where this value of material which you obtain is fitted and which type of bearing material will give this value of PV. So you can see from here, whatever is the value, kilopascals, it is here, it is mentioned that tin Babbitt. So you have to find where is a tin Babbitt and that material is giving this value of this 1050 kilopascal meter per second. So Babbitt high tin content 89%. I'm just showing it here. Please see this. Is giving the value of PV factor which you obtained from the above calculations. Okay. Now step 10 to 11, nominal diameter clearance. You will select the nominal diameter clearance. You know the journal diameter. You know the radial. You know the speed of the shaft. It is rotational per minute and it is per second. So from here, you know the journal diameter. You can see what is the radial clearance which is to be adopted. Now from figure below, we can recommend a minimum CD is equal to 0.002 inches. 0.002 inches, it comes here. This are 50 microns. Based on D is equal to 38 and N is equal to 500 RPM. When you go 38 and 500 RPM, it comes here. So it will cross here. So your radial clearance curve will be valid here. This 0.002
13 hours.
50 microns. So you have select the clearance. Then these are the further properties of dry wrapping bearing materials. You can see here. Properties continued. This is wear rate of dry bearing material. Now here I am just showing some plane surface bearing failures. But I will not discuss today in this lecture now at this point. I will discuss it tomorrow. But today I will upload two videos. One is where we stopped previously, and this video also you can see on website. So up to this point, what I have seen, what I can understand that you can design, you can select a bearing material, and you can also select a clearance. But we are not still able to see how much temperature it will give, and also what will be the life of the bearing. Now that I will discuss in the future lectures, and also I will discuss these plane surface bearing failures are very important to know for as a designer. Then once we are through this, and then we will have the satisfaction that we have completed this plane surface bearing. So today you will just try your numericals from the book or any application for design of plane surface bearing. So you can take any load, you can take any speed, and you can take general diameter, and then you see which type of material is able to be, you will give that property a PV. Then you will also find the clearances, and then we will have next time discussions on wear. I am unmuting all of you. Okay. Have you today? I'm not recording for other things. I will stop recording.